Here we are out at the experiment station plots on the St. Paul campus, and we're looking at a field that was previously grown with corn, but a moldboard plow has completely inverted all of the crop residue and buried it. What I wanted to show you here was soil texture, that is particle sizes. And you may be able to see some differences in color as I scan through this particular plot, particularly down here where we have some lighter tan colored soil. This is actually soil that when the moldboard plow went through was pulled up from further down, maybe a foot down in the field, and inverted and brought to the surface. This is soil that hadn't had as much organic matter incorporated, so it's lighter in color. But I also wanted you to notice how shiny this surface is compared to the darker soil. One of the reasons that it's shiny is the moldboard plow scooted along this surface. It's very high clay content in this soil, the smallest particle size, and it creates almost a smear of this clay soil. And you can see this, it's rather hard soil, hard to break. I think if we fired it in a kiln, we could almost make pottery out of it. Well, it's not quite that bad. You can see that once I whack at it a little bit, it does crumble a bit because there's not bad organic matter in this soil, actually. So the soil structure is not too bad, and that's because on this campus there are also large animals that are housed, and the manure is spread on these fields. So what we have here is a loam soil that's high in clay. You can see this in the smearing, particularly in the soil that was buried down below the surface and not exposed to much animal waste in the past. But still not too bad as far as clumping and aggregation caused by humus.